Okay, so I'm going to explain here why we need to use trig substitution. The goal is to remove radicals in the integrand. And how will we remove the radicals? Using trig functions. There are three basic types. These are the a squared minus u squared. The second type is u squared minus a squared. And the third type is a squared plus u squared. This can also be written as u squared plus a squared. How will we remove these radicals? Let's look at the first one. A squared minus u squared actually represents a side of a right triangle. We note that in a right triangle, the longest side is the hypotenuse. So by looking at this form, this should be a and this should be u. So that when we use the Pythagorean theorem, this will give us a squared minus u squared. Now, if my angle is here, then you're gonna use sine of theta is equal to u over a. And that's how you get the form u is equal to a sine of theta. Now you might ask, is it also possible to draw the triangle this way? Can I put my a here and my u here? In as much as this is the same, right? Well, sure enough, we can do that. But in this case, instead of using sine, you will use cosine of theta. Cosine is adjacent over hypotenuse, so this is gonna be u over a, and will give us a cosine theta is equal to u. Now the problem is, we want to remove the radical sign, okay? And so let me show you how to do that, okay? But first, let's look at the other forms, okay? The other form is u squared minus a squared. In this case, my u is the hypotenuse, and this could be a, or I can draw it this way as well. This is u, and this could be a. Either form is fine, but you will just have to use different trigonometric functions. In this case, if I'm using this form, then I will have to use here secant. Secant of theta is equal to hypotenuse over adjacent. In this case, what will I use? I'm gonna use cosecant of theta, which is equal to u over a. This will give us u is equal to a secant theta. This one will give me u is equal to a cosecant theta. Now, what about the other side? Well, that should be the other side. This is gonna be u squared minus a squared. This is gonna be u squared minus a squared. The third form is the a squared plus u squared. And this could be done in either form, okay? Now, the triangle associated with this is this. That must be the hypotenuse because it's the square root of a squared plus u squared. So this could be your a, and this could be your u, and this will be a squared plus u squared. Or you can draw it this way as well. If this is a squared plus u squared, this could be your u, and this could be your a. If this is the case, then you're gonna use here the tangent. Tangent of theta is equal to u over a, which will give you a tangent theta is equal to u. If this is the case, then you're gonna use cotangent. Cotangent of theta is equal to u over a, and so u is equal to a cotangent of theta.